So let me see what is the answer for the homework question. That is given a random sample of size n from log normal with mean mu and variance sigma naught square distribution. Construct MP test for testing h naught mu equal to mu naught versus h1 mu equal to mu1. Right? In there is two cases. Case 1, mu1 is greater than mu naught. And second case is mu1 is less than mu naught, right? So here the answer for the first question, that is a case 1, that is a mu1 greater than mu naught. So we know that we reject null hypothesis for the large ratio, right? That is a rejection region. In the problem it's given that a random sample of size n, right? So we have to take the likelihood function, that is likelihood under alternative hypothesis divided by likelihood under null hypothesis, right? Greater than k, then we reject the null hypothesis. Under h naught we know that x follows log normal with the mean mu naught and variance sigma naught square, and this is the likelihood function of log normal with the mean mu naught variance sigma naught square, and this is likelihood under h1. So then we want to take the ratio of that likelihood function, right? After substituting value of likelihood under h1 divided by likelihood under h0, then we will get the term, this term, right, which is greater than k1 value. So we have to simplify that terms. Then we can write these terms as like these. Then we take a log on both term. Okay, then we will get minus 1 by 2 sigma naught, that term, same term. Then we have to simplify this term, right? And after simplifying we cut the terms. Then we can rearrange these term as this type. Here minus 1 by 2 sigma naught square into the term greater than k2, right? So here we want to divide the term by, sorry, here you want to multiply the term by into minus 2 sigma naught square, right? Then here this inequality changes, right? Here we multiplying by minus 2 sigma naught square, right? Then here this term cancel, then the same term which is less than k3. What is k3 there? K3 equal to minus 2 sigma naught square k2, right? Here sign changes, right, because it multiplied by my negative sign. Then we will take this term here, that is minus 2, the remaining term minus 2 which is greater less than k into k plus, sorry, k minus this term, right? Then here we know that mu1 is greater than mu naught, right? So this is a positive value, and also here a minus sign, right? So minus into plus is minus, right? So we have to take these minus 2 into mu1 minus mu naught, this is a negative term. So here we want to obtain the test function, right, which means the function of a random variable. So we want to cut the terms, right? We want to change this term like function of a random variable, so that we have to divide the term, that is minus 2 mu 1 minus mu naught, right? Here we want to divide by negative sign, right? So then the sign changes. Then we can get the term summation log xi, which is greater than k3 minus n mu1 square minus mu naught square divided by minus mu1 minus mu naught. See, negative term, right? Then here sign changes. That is the rejection is equal to summation log xi greater than k. From that we have to say that MP test for testing H0 versus H1 is phi of log xi equals 1 if summation log xi is greater than k. That is, we reject H0 when summation log xi is greater than k with probability 1. Then we reject H0 summation log xi is less than equal to k with probability 0. Right? Here we want to obtain the k value, right? For that we have to use a size condition. We know that x follows a normal with mean mu and variance sigma naught square. Then summation log xi follows normal with the mean and mu naught, variance and sigma naught square, right? So here similarly in the last problems we want to obtain the k value, also power of the test. And in the case of in the second case, that is a mu 1 is less than mu naught. So here these all terms are similar, right? Ratio, then substitution after simplifying. So here greater than k, right? Then here is a multiplied by minus 2 sigma naught, right? Here sign changes, that is less than k3, right? After these here we want to obtain what is the value of these, that is a minus 2 into mu 1 minus mu naught, right? That is, here is given that in the case 2 mu 1 is less than mu naught, right? So here this value is negative, right? So negative into this value is negative, right? Less than 0. Here negative into negative positive, right? So we have to divide by this term, that is minus 2 into mu 1 minus mu naught. This term is positive, so we want to divide by that term, that is 2 into mu 1 minus mu naught. So it also remain the same sign, that is summation log xi less than k. Then MP test for testing H0 versus H1 is summation phi of summation xi equal to 1 summation log xi less than k. So here also we have to obtain the value of k, right? Similar like last problems, that is a summation probability of summation log xi less than k equal to alpha. Then we want to write this term, right? Because here less than, we want to make that is a greater than term. For that 1 minus alpha here, all right? That is k equal to n mu naught plus z 1 minus alpha square of n sigma naught square. Similarly the power of the test. Okay, here we want to substitute the value of k, right? So this is the last homework problem. Now we will go into prove solve one discrete distribution problem. Okay, the problem is given a random sample of size n from Bernoulli distribution for testing H0 p equal to p naught versus H1 p equal to p1. Construct most powerful test for testing H0 versus H1. In this problem, it contains two cases. Case 1 is p1 is greater than p naught. Case 2 is p1 is less than p naught. Okay, we will solve this problem. So solution. Here we know that x follows Bernoulli with the parameter p, right? Then what is the PDF PMF for? It is PDF or PMF? PMF, right? Because it is a discrete distribution. Then what is the PMF of Bernoulli distribution with parameter p? Probability of x equal to x equal to p power x 1 minus p power 1 minus x, right? Then x equal to 0 comma 1, right? But in the problem is given that it's a random sample of size n, right? So we want to take here the likelihood function, right? What is likelihood function? Likelihood L comma L of likelihood of parameter p, then x1, x2, so on, xn, the random variables, right? Equal to product of I1 to n, probability of x equal to xi, right? Which is equal to, what is that, product of I1 to n p power xi 1 minus p power 1 minus xi, right? So which is equal to product of p power xi equal to p power summation I 1 to n xi. Then here 1 minus p power n minus summation xi, right? We will write these term as a probability of summation xi I 1 to n. You can write these term as 1 minus p power n divided by 1 minus p power summation xi I 1 to n. Similar, right? 1 minus p power n minus summation xi as you can write these term as 1 minus p power n divided by 1 minus p power summation xi, right? So we can write these term as p by this p by here p power summation xi, right? Here also 1 minus p power summation xi. Then we can write these terms together, that is p divided by 1 minus p whole power summation xi, right? I from 1 to n, then 1 minus p power n, right? Under h naught, under h naught, likelihood of p naught. Here h naught is p equal to p naught, right? That is likelihood under h naught is likelihood of p naught x equal to p naught divided by 1 minus p naught power summation I1 to n xi 1 minus p naught power n, right? Then what is the under h1? That is likelihood under h1 is equal to p1 divided by 1 minus p1 power summation I1 to n xi into 1 minus p1 power n, right? So in this problem we have to construct we want to construct the most powerful test for testing h0 versus h1, right? From the Neyman-Pearson lemma we know that we reject h0 for the large ratio, right? From Neyman-Pearson lemma we reject h0 if f1 of x divided by f0 of x is greater than k, right? But here you want to find the ratio of likelihood, right? Because it in the problem it's given that the random sample from size n, right? That is a likelihood under h1 divided by likelihood under h0, right? Which is greater than k1, which implies we want to substitute the value of likelihood under h1 and likelihood under h0, right? That is a likelihood under h1 is p1 divided by 1 minus p1 power summation xi into 1 minus p1 power n divided by likelihood under h0, that is p0 1 minus p0 power summation I1 to n xi into 1 minus p0 power n, which is greater than k1, right? Which implies we can write these term as is here 1 minus p1 power is 1 minus p1 divided by 1 minus p not power n. These two term. Okay, here. Then we can write these term as okay. It is p1 divided by 1 minus p1 power summation xi, and we can write these term as 1 minus p naught divided by p naught power summation xi, right? Similar, right? 1 by p naught divided by 1 reciprocal of these term is, we can write reciprocal of these term as 1 minus p naught divided by p naught power summation xi, right? It is greater than k1, right? Then we can write these two terms together because the powers are same, right? This is 1 minus p1 divided by 1 minus p naught power n, then p1 into 1 minus p naught divided by 1 minus p1 into p naught, right? Whole power summation xi, right? Which is greater than k1. This term, okay, we can write this term as like this, right? Then so we here we want to find out the test function, right? The most powerful test function. So that is the function of random variables, that is a summation. Here the function is a summation xi, right? So we want to find out summation xi is greater than k or less than k.